Welcome everyone. Welcome to another episode in my climate change debunking series. In this episode, I will be debunking climate change with a comparison of the scientific property of water with that of carbon dioxide. And as such, I will illustrate definitively how insignificant carbon dioxide is in in, in affecting the climate as compared to the enormous influence that water have over the climate. So sit back, relax, and enjoy this episode. It will be very informative and will open your eyes to the reality that water is the number one driver of climate change or climate preservation on Earth. Enjoy. We will first take into consideration of how abundant water is on Earth. Much of us take for granted how much abundant water is on Earth, especially those who live on dry, arid lands. Even in these dry areas, water can be found abundant underground. And as you can see from this slide, to your right, to your left, two-thirds of the Earth, 71%, or more than two-thirds of our planet is covered by water. Absolutely to 71%. That shows you how abundant water is. 97.2% of that water is salt water, which is found in the ocean, and only 2.8% of the water on Earth are fresh. And a majority of fresh water is beyond our reach and locked up in polar snow and ice, and less than 1% available for consumption. So fresh water albeit there's a lot of water on Earth, a very small percentage of that is fresh and and available to us, and it's this 1% is usually made available by the water cycle that evaporates water from mainly the sea, converted to fresh water, and brings it by the cloud over to land. That's why a lot of people would say that water is a scarce commodity on Earth, but relatively it's not. We will now have a look at the unique um, specific unique properties of water. We just have a list of them, and these are the properties that we will be exploring in this presentation, and they are as follows. One, high polarity. Water has a very high polarity, and therefore it is a very good solvent. High surface tension, high specific heat capacity, low thermal conductivity, high heat of vaporization compared to its heat of fusion. It has a high heat of vaporization and a low heat of fusion. Low density as a liquid, as a solid, meaning that ice is lighter than water, and a relatively low density as a vapor as compared to air. So these are the qualities that listed here that we'll be exploring in this presentation. On this slide, we will be going into a bit more detail into each scientific property of water, and as you can see, the properties are listed on your left, and it shows the unique what is unique about this property, and on the right, the important to nature. For instance, as you can see, density. Water expand upon freezing with a maximum density at 4 degrees Celsius. And what is important of this? It causes water to form upon ice and enable life to continue under the ice. So water get dense, less dense as it freezes, and and therefore water doesn't freeze from the bottom but from the top. Also, the melting point. Water have an abnormally and high melting point. This allows water to exist as liquid on Earth. The same thing with the boiling point. Specific heat capacity. Water has a third highest specific heat capacity after helium and hydrogen. This allows water to be a very effective moderator of temperature extreme. Water, an important one is the latent heat of vaporization, the highest known. This is important as it enables a very important removing huge amount of heat from the sun heated surface to the atmosphere in the water cycle. And latent heat of fusion, it is relatively low compared to that to the latent heat of vaporization. Ensure water is or form or melt quickly in the presence of our thermal energy in order to preserve life on Earth. Surface tension, water has a very high surface tension. This affects the cloud formation, cloud and rain formation, and the uptake of water by plants. Absorption of radiation, water have a multiple absorption spectrum along the infrared and ultraviolet radiation wavelength. Um, and this causes water to be directly eat up in the ocean, in the river, in the lake, and in the Earth's surface, and on the clouds and water vapor in the atmosphere, making life possible on Earth again. Solvent property. Water is an excellent ionic solvent due to its bipolar nature, important in the transfer of dissolved substance into our biological sustaining systems. And thermal conductivity, relatively low. Another important temperature moderating quality, preventing temperature from rising or falling too quickly, and thus important to the preservation of life. We will now have a look at the importance of a substance having a very high specific heat capacity. And as you can see from your right, uh, listed in listed from highest to lowest is hydrogen, helium, water, fresh and salt water, and then the human body. So what is important in having such a high specific capacity? So these are the substances with the highest specific capacity. Our sun is made up of two elements, hydrogen and helium, and the sun consists of 70.6% hydrogen and 27.4% helium. These are the first two elements elements with the high specific capacity as listed on your left. Hydrogen is combined by nuclear fission to give helium and a huge amount of energy that warms our Earth, some of which warms our planet. So it's important to see that these two elements are has very high specific capacity and they are found in the sun. The next two substance is water, and Earth surface is 71% fresh for water, fresh and salted. The substance with the third highest specific capacity after hydrogen helium, which what makes life on Earth possible by effectively moderating the thermal energy from the sun. This is no coincidence, none whatsoever. Finally, the human body or tissue also have a very high specific capacity in order to also be effective in moderating of thermal energy to sustain life. And as we all know, the human body is also comprised of at least 70% of water. This is no coincidence. So therefore, we're just showing how important it is that these life-sustaining elements and have very high specific capacity in order to deal with heat, to generate heat, and to moderate heat. The water cycle. As you can see from the diagram, this is a diagram depicting the various stages of water cycle, where we have evaporation and transpiration, condensation, precipitation, sublimation, and we can see that water is moved from one from land to sea by evaporation. This is a water cycle. This is a well-known cycle of nature, but we need to understand the importance of such a cycle. Water is the only known substance on Earth that occurs naturally, as in all the three states of solid, liquid, and gas. Important, the only known substance on Earth. It is this ability to transport between these three states that makes water the great temperature, weather, and climate controller and moderator. Very important. It is this ability to transform between these three states that makes water even more possible in making life possible on Earth. Existing in all three states give water the ability to move in enormous amount of heat and substance around the world, and from the salty sea, and convert the fresh water to making life fresh water available to all facets of life on Earth, on the land. Water cycle, the great climate controller and moderator. Despite its relatively small amount in the atmosphere compared to oxygen and nitrogen, water vapor has a huge influence on the planet's temperature regulation. As you can see from the diagram on your right, where you have water going from the various stages of solid, liquid, and gas, with the name in orange and blue to show the name that's going from one state to the next, and showing latent heat absorbed or latent heat release from the process of each transition. On average, about 500,000 kilometers square of volume of water is evaporated each year, mostly from the ocean, a small percentage from the land. Water vapor is a major driver of the Earth's weather and climate, as it is evaporated from the Earth's surface, rises in the atmosphere, forming clouds, transporting and depositing latent heat with it to the colder upper troposphere, and moving fresh water over to the land. Very important. Water evaporation from the tropics are constant and enormous, but less so in the temperate land, and even more so in the polar region. And in this region, condensation and in the polar region, condensation and sublimation outstrip evaporation, causing the form of a buildup of ice in polar regions. Huge amount of latent heat is locked up or released by water vapor as they transform from solid liquid to gas, and vice versa, a process that moderates climate and prevent climatic temperature extremes. If the health of the water cycle is compromised in any way, a marked detrimental change will be reflected in the climatic environment. Without the huge heat releasing valve of the water cycle, the Earth would be extremely humid all around the planet, leading to the melting of all life, all ice on Earth. We will be now looking at the factors affecting water cycles. The main cause of climate change in a particular area is due to the systematic destruction of the water cycle. Removal of trees and plants that hold the soil together and control the runoff, and other physical corrosive effect of rainfall. Soil erosion is a natural process in which the topsoil of a field is carried away by physical sources such as wind and water. Soil erosion and the reduced ability of the remaining soil to hold and control the runoff of subsequent rainfall lead to a precipitous decline of the water cycle in that area. The land reduces its ability to retain moisture and is more susceptible to the ravages of the sun. The main causes of soil erosion are as follows. improper and poor farming practices, unlimited deforestation, uncontrolled animal husbandry, unplanned and unchecked urbanization. We will now be looking at the importance of evaporation and condensation. Water and water vapor has a very wide and intense absorption affinity for the sun incoming infrared and ultraviolet radiation. This energy is instrumental in the transformation of water to its vapor. The reversible water to water vapor process of evaporation and condensation is important for the following reasons. It creates a superhighway for the heat removal from the planet surface to the cold upper troposphere. 2. It creates clouds and moves huge amounts of fresh water evaporated over the sea and ocean and lake to the land masses to support life. 3. It creates clouds that also reflects and absorb much of the incoming near-infrared radiation from reaching the Earth's surface in the first place, a cooling effect. It creates cloud that also traps and absorbs some of the terrestrial infrared radiation reflected by the Earth's surface, therefore tempering the heat loss to space, especially at night and winter time. The cooling down of the Earth's surface by the rain as the cloud precipitates rain and falls back down to the Earth's surface. Land water retention. It is important to note that the reduction of the land surface water carrying capacity, and with it the compromise of the water cycle, is a major cause of climate change in a particular region. Water is retained on land in the following ways. Water is retained in the soil, the wetlands and swamps, deltas, so on and so forth. 2. In the plants themselves, there's a lot of water. The plant has a high percentage of water in them, and it's directly linked to this water in the soil for life. And 3. In the rivers and streams that feed the water to these plants and to the soil. So these 3 areas in which water is retained on the land. The more plant cover and the slower the runoff of the surface water, 1. The higher the land water retention rate. 2. The more resistant the climate will be to climate change, especially in tropical climate, more so in tropical climate. And 3. The more diverse the plant and animal that this climate can support. So land water is very important, and it's important for the land to be able to retain this water. By retaining this water, it sustains the water cycle in that area, and as we know, the water cycle is what protects the land from the harsh, strong, powerful rays of the sun. For the rest of the presentation, we will be comparing carbon dioxide with water, the properties of carbon dioxide with that of water, to show how insignificant carbon dioxide is as compared to water in climate change. And in this first slide, we will be comparing carbon dioxide and water, the abundance between the difference between these 2 elements. First of all, it's important to say that the comparisons in the abundance is absolutely overwhelming. This is a critical difference in water and carbon dioxide effect on the atmosphere. And as you can see from the diagram on the right, carbon dioxide only makes up 0.4% of atmosphere, Whereas in the atmosphere itself, water vapor can range up to 4%, which is a 10,000 um, more increased that as compared to carbon dioxide alone. So water vapor compared to carbon dioxide in the air is 4% as opposed to 0.4 carbon dioxide. They're alone. I'm only talking about water vapor. We're not talking about ice or water in the land. Cloud, which is also suspended in the atmosphere, is equivalent to all the river's water on the Earth's surface. So the amount of cloud in the amount of water in the clouds is equivalent to all the river's water on the Earth's surface. That much water. Ice on the Earth's surface is 1.527% of the Earth's surface. Fresh water is 1.988% of the Earth's surface, and seawater is the whopping 69% of the Earth's surface. Combined Earth's surface water is 71%. So compared to this small, minuscule percentage in the atmosphere, we can see that water swamps, literally swamp the existence of carbon dioxide in the atmosphere in regards to abundance. Very important. We will now be comparing carbon dioxide to water in regards to their each related properties. And as you can see from the table, we have the each related properties of a specific heat capacity, thermal conductivity, infrared wavelength absorbency. And as you can see, carbon dioxide has the lowest specific heat capacity. In regards to specific capacity, it has the lowest in compared to all the other form of water. For instance, water vapor, which is a gas, just as carbon dioxide, has more than twice the specific capacity of carbon dioxide. Cloud, which is cloud fine suspended water vapor in the atmosphere, has more than 4 times the specific capacity of carbon dioxide. Ice, twice, and fresh water and seawater also has 4 times the carbon dioxide, the specific capacity of carbon dioxide. And this is an important heat related factor, as we all have explained in previous slide. The importance of temperature moderation of these very important thermal properties. In regards to thermal conductivity of a substance affect the ability to warm up and cool down fast, as the rate of warm up and cool down. The lower the thermal conductivity, the slower heat will spread within the substance itself. So carbon dioxide and water vapor has very low thermal conductivity, similarly low. So in that regards, there's not much different. But if you look at the cloud, ice, and other forms of water, you see it's significantly greater. For clouds, the thermal conductivity is 0.61, which is about 33 times that of water vapor. So therefore, therefore it is easily transferred in clouds and fresh water as compared to water vapor, which is important in climate, in rain and weather and climate. As you can see in green, ice has a very high thermal conductivity compared to the rest of the water, and much more higher than carbon dioxide. And this factor if you look at the overall important thermal conductivity, the high thermal conductivity make ice melt easily in the presence of thermal energy, which is important to life in the polar region. So the quicker ice can melt into water, it's better for all life form that lives in that area. In regards to infrared wave absorbency, again, carbon dioxide is only absorb infrared wavelength at two very specific wavelength, and they're rare on Earth. They come from very rare Earth surface temperature source. In regards to water, water in all its form absorb infrared radiation from multiple wavelengths across its spectrum in every form, whether it's seawater, freshwater, ice, uh, cloud, or water vapor. And these factors make, for instance, water vapor very important and integral in Earth thermal energy manipulation, making it the most important greenhouse gas. And in regards to cloud, also a very important and integral part in thermal energy manipulation. In regards to fresh water, most life forms need fresh water to survive, and it's found mainly in rivers and lakes and streams. Also, seawater with its high specific capacity and medium to low thermal conductivity provide a great living environment for marine animals, and also a great temperature moderator around the world via sea current. Sea current moves hot water, warm water from the tropic, moving it to the colder temperate polar region, and it's important to eat moderation. And again, Earth combined water surface is 71%, which make water a powerful thermal controlling force. So as compared to carbon dioxide, um, you can see that water in all its form dwarfs carbon dioxide, the effect of carbon dioxide in any atmospheric influence that it might have, making carbon dioxide in effect very insignificant in Earth thermal manipulation, atmospheric thermal temperature manipulation and influences. In this our final comparison between carbon dioxide and water, we will be looking at both relative density between the two substances, and relative density is the density compared to their density is compared to the average of the air, average of nitrogen, oxygen, water vapor, carbon dioxide, everything will be compared to the density of these substances themselves. And as you can see, carbon dioxide in regards to density has the highest density in regards to a gas. We're talking about a gas now, anything in the atmosphere, compared to water vapor, it is much heavier than air. And as compared to the relative density, carbon dioxide is much heavier than air. And there's a reason for that. Because it's heavier than air, it will sink. It will not be suspended in air. It tends to want to settle down to to the lowest surface area, to sea level. In regard, this important to nature. It stays close to the Earth's surface for the benefit of plants, and not important or useful in the transportation of thermal heat between the Earth and the troposphere. So it's heavier than here. So it's settled out. It tends to want to settle out of the atmosphere as close to the Earth's surface as possible. As opposed to carbon dioxide, atmospheric water vapor, which has a density of 0.79 kilograms per meter square, is much lighter than here. Lighter than here, it means it has a tendency to want to float up, to move up into the atmosphere. This is very important in transportation of thermal energy from the sun heated surface to the troposphere for disposition. So because it's lighter than here, it tends to want to, once water evaporates, it tends to move upwards into the atmosphere, taking away the heat from the heated surface. Cloud, for instance, cloud which is suspended water vapor in the atmosphere, has a density of 1, which is just lighter than here, meaning that being just lighter than air, it tends to suspend in the air. And the importance of this suspension is that it has many benefits of having lingering in the atmosphere in regards to holding water for eventual precipitation to back to Earth, for blocking the sun from coming through, too much sun coming through, and for eating up with solar incoming solar radiation. So it's important for the water vapor, uh, water droplet as sun as cloud to suspend in the air, and it's only possible because what because the density is just lighter, just above lighter than here. Here, um, air average density is 1.21. So the cloud having a 1.0 density make it just lighter than here, enough for it to set to suspend into the air at a certain specific height. When you look at ice, fresh water, and seawater, we see that, of course, the density of liquid is going to be so much more than that of gas, as you can see from ice, which is 98 kilogram, 918, water 997, and seawater 1030. So as you can see, seawater has a much is much evident here, but ice density, um, ice ice lower density than fresh water or salt water make ice forms and float and their surface, which is important to life, especially in polar zone. Also, the reason it is the reason why rain falls from clouds when the drop get big enough and density breach that of air. So as water precipitate, it becomes denser and denser, and eventually it cannot hold the hair cannot hold it as it becomes heavier than the relative density of air, and therefore it falls at sea as fresh water. Seawater, which is also much evident here, makes seawater much more buoyant, and the important benefit of sea travel and transportation. And for the combined water surface, ensure that water is always at the lowest level as possible, and it's called the sea level. So the relative density compared to carbon dioxide and water shows that it's because of one is so much more evident than the other. They play very different role in sustaining life on Earth. Water in terms of temperature control, and carbon dioxide in terms of being close to the plants, as close to the Earth's surface as possible, to feed the plant, to make glucose, starch, and other important um, um, proteins for Earth, for life on Earth. So there you have it. In this slide, I will be summarizing how carbon dioxide has little effect on climate as compared to water. So CO2 versus H2O. Gonna have a recap. Water's scientific facts and property absolute dwarf that of carbon dioxide regarding its effects on climate due to the following reasons. The sheer volume and abundance of water on Earth's surface and atmosphere in the form of solid, liquid, and gas, whereas carbon dioxide only exists as a trace gas in the atmosphere. Number one. Number two, water exceedingly high latent heat of fusion and vaporization as it transforms from one state to another. Carbon dioxide occurs naturally only as a gas in the atmosphere and has no state transformation latent heat associated with it. This is exclusive to water. Number three, water vapor and the clouds are lighter in here in relative density, which make them important in thermal energy movement between the Earth's surface and the atmosphere. Carbon dioxide is much heavier than air and much rather remains close to the Earth's surface, and thus does not play a role in transferring heat to or from the atmosphere. Water absorption of multiple infrared radiation from the full spectrum of infrared radiation band in all its various states, make it important again in heat production, movement, deposition, and conservation. Carbon dioxide has no such natural absorptions of nor interaction with infrared radiation, and only in a few exceptional cases. Water vapor concentration in the atmosphere can be as much as 10,000 times that of the concentration of carbon dioxide, making it that much more exponentially effective if all other scientific facts are held equal to that of carbon dioxide. Water exceedingly high specific heat capacity in all states, especially in the liquid state, which can be up to 5 times that of carbon dioxide, mean that it can heat up much slower, hold much more thermal energy, and cool down much slower than carbon dioxide, making it the number one greenhouse gas in the atmosphere. The vast amount of heat water traps and easily transferred around the earth. Carbon dioxide like to remain cool and will readily give up any excess heat it absorbs to all the other atmospheric gas surrounding it. It likes to remain cool. It likes to pass on the heat that it receives, whether from conduction, convection, or radiation. It doesn't matter how it acquired heat. It likes to pass it on back to the cooler, much cooler water vapor or carbon dioxide or oxygen molecule that surrounds it. The high and effective rate at which water can capture, transfer, deposit heat between the sun-heated surface and the colder upper troposphere level. Carbon dioxide molecules are big, weak, sluggish in comparison, and has no interest in providing that service to mankind. So therefore, carbon dioxide in every respect is scientifically pale and very insignificant in comparison to water vapor in regards to climate change and the control of water. So this will definitely prove that the big hoopla that the climate alarmist is making concerning carbon dioxide is absolutely ridiculous, and they can't and they shouldn't, because water absolutely dwarf all of these any effect that carbon dioxide might even have on the atmosphere. It absolutely wipes it out. So this definitely shows that we need to stop giving the importance that carbon dioxide play any importance that carbon dioxide play in regards to climate change. It does not plays any role, and it needs to stop. It needs to stop. Absolutely needs to stop. Thanks and appreciation. I would like to thank you all for taking time to watch this presentation. Hope you found it as entertaining as it was informative. Keep on learning, keep on being curious, keep on researching. Knowledge is power. It's only with knowledge that you can understand what others' intention have, what other intention are up to you, and how you can protect yourself and defend against people who has bad intention for you. Keep on learning, never stop learning. Thank you.